We often think of the universe as a vast, empty void, a silent stage where nothing happens for billions of years. But if we could speed up time, if we could watch the cosmos unfold over eons in a matter of minutes, we would see a sight so spectacular it defies imagination. We would see that the universe is not static. It is alive with motion. We would see colossal cities of stars, billions of light years across, twirling, diving, and crashing into one another in a spectacle of unimaginable scale. This is the grand cosmic dance of galaxies, a choreography written by gravity and performed across the canvas of infinity. Today, we step back from our tiny corner of the Milky Way to witness the epic life stories of these island universes and the invisible forces that drive their magnificent movements. For most of human history, we didn't even know galaxies existed. When astronomers looked through early telescopes, they saw faint, fuzzy patches of light they called nebulae. They assumed these were just clouds of gas within our own star system. It wasn't until the 1920s that Edwin Hubble used the world's largest telescope at the time to prove that some of these nebulae were actually entire universes of their own, located millions of light years away. This discovery instantly expanded our reality from a single galaxy to a universe containing hundreds of billions of them. As we began to catalog these distant cities of stars, we noticed they come in a stunning variety of shapes and sizes. There are the majestic spiral galaxies, like our own Milky Way or the famous Andromeda. These are the ballerinas of the cosmos, with elegant, winding arms made of gas, dust, and newborn stars spinning around a bright central bulge. Then there are the elliptical galaxies, which look like giant glowing footballs. These are often the retired elders of the universe, filled with old red stars and very little gas to make new ones. Finally, there are the irregulars, chaotic, misshapen clusters of stars that have often been mangled by gravitational encounters. But regardless of their shape, every galaxy is held together by two things: a central anchor and an invisible glue. At the heart of almost every large galaxy lies a monster, a supermassive black hole. These aren't your typical black holes born from a single star. These are titans with the mass of millions or even billions of suns. Our own Milky Way harbors Sagittarius A*, a black hole 4 million times the mass of the Sun. While they are tiny compared to the size of the galaxy itself, they exert a profound influence. They act as the gravitational sun for the galactic center, but they also act as cosmic thermostats. When these black holes feed on gas and stars, they blast out jets of radiation and energy that can blow gas right out of the galaxy, effectively stopping the birth of new stars. It is a delicate, violent balance between the hunger of the whole and the life of the galaxy. But the real drama begins when we look at how galaxies interact with their neighbors. In the vastness of space, galaxies rarely travel alone. They exist in groups and clusters, bound together by gravity. And within these clusters, the dance turns into a contact sport. Gravity is a relentless choreographer. When two galaxies pass near each other, their mutual attraction begins to pull and stretch them. We call this tidal interaction. Long tails of stars and gas are ripped away, stretching for hundreds of thousands of light years like celestial ribbons. Eventually, the dance leads to a collision. But a collision between galaxies isn't like two cars hitting each other. Galaxies are mostly empty space. If you imagine a galaxy as a swarm of bees, and another swarm flies through it, the individual bees rarely actually hit one another. Instead, the gravitational fields of the two galaxies mesh and mingle. The gas clouds within them, however, do collide. They compress and heat up, triggering a starburst, a frantic, sudden explosion of new star formation. Thousands of brilliant blue stars are born at once, lighting up the merging galaxies like cosmic fireworks. This is the fate that awaits us. Right now, the Andromeda Galaxy is hurtling toward the Milky Way at 250,000 miles per hour. In about 4 billion years, our two galaxies will begin their final dance. To a future observer on Earth, if any remain, the night sky will be filled with the distorted glowing core of Andromeda as it begins to merge with our own spiral arms. Eventually, the two will settle down into a single, massive elliptical galaxy, often nicknamed Milkdrometa. The individual stars will survive, but the spiral shapes we know today will be gone forever, sacrificed to the grander structure. While we can see the stars in the gas, there is a secret ingredient to this dance that remains invisible to our eyes. When astronomers measure how fast galaxies spin and how they move in clusters, the math doesn't add up. There isn't nearly enough visible matter to provide the gravity needed to hold them together. They should be flying apart. This led to the discovery of dark matter, a mysterious, invisible substance that makes up about 85% of all matter in the universe. Every galaxy sits inside a massive halo of dark matter. It is the invisible scaffolding of the universe. Without it, galaxies could never have formed in the first place. Dark matter provided the gravitational wells that pulled in the first clouds of hydrogen after the Big Bang. It is the silent partner in every galactic merger, the unseen hand that guides the movements of every star. We cannot see it, we cannot touch it, but without it, the cosmic dance would come to a crashing halt. If we zoom out even further, beyond individual clusters, we see the true scale of the dance. Galaxies are not scattered randomly through space. They are arranged in a magnificent web-like structure known as the cosmic web. Huge filaments of dark matter and galaxies stretch across the void, connecting massive superclusters. Between these filaments lie voids, vast, empty bubbles of space millions of light years across where almost nothing exists. On this scale, the dance is one of expansion and structure. We are seeing the universe grow. But there is a twist in the story. While gravity is trying to pull galaxies together, a mysterious force called dark energy is trying to push them apart. For billions of years, gravity had the upper hand, allowing galaxies and clusters to form. But about 5 billion years ago, dark energy began to win the tug-of-war. The expansion of the universe is accelerating. While the Milky Way and Andromeda are bound together and will merge, the distant clusters of galaxies are moving away from us faster and faster. In the very distant future, hundreds of billions of years from now, this expansion will become so fast that the light from other galaxies will never be able to reach us. The Milky Way, or Milkdrometa, will become a true island universe, surrounded by an infinite black void. Every other galaxy in the sky will have vanished beyond the cosmic horizon. We are living in a privileged window of time where we can still see our neighbors and witness the grand dance. The life of a galaxy is a story of hierarchical merging, small things becoming big things. The first galaxies were tiny, chaotic clumps. Over billions of years, they ate each other, grew, developed spirals, and eventually merged into giants. Our own Milky Way is a cannibal. We can see the fossils of smaller galaxies it has swallowed in the past, and we are currently in the process of consuming small satellite galaxies like the Magellanic Clouds. It is a cycle of destruction and rebirth that builds the complexity of the universe. Why does this matter to us sitting on a tiny rock orbiting an ordinary star? because the dance of galaxies is the reason we have a home. The star-forming regions triggered by galactic interactions are where the heavy elements needed for planets and life are created and distributed. The stability provided by our galaxy's spiral arms gives our Sun a safe circular orbit, far away from the chaotic radiation-filled center. We are the products of 13 billion years of galactic evolution. When we look at a photo from the Hubble or James Webb telescopes, like the famous Deep Field, we see thousands of galaxies in a tiny speck of sky. Each one of those dots is a home to billions of stars, untold numbers of planets, and perhaps countless civilizations. Each one is currently performing its own version of the dance. Some are drifting peacefully, some are mid-collision, and some are just beginning to form from the primordial mist. The grand cosmic dance reminds us that we are part of something so much larger than our daily concerns. We are part of a structure that spans the entirety of space and time. We are the observers of a masterpiece that has been in production since the dawn of time. Every star in our sky is a member of a great celestial city, and every city is a part of a cosmic web that vibrates with the energy of creation. As we conclude this chapter of our journey, take a moment to imagine the scale. Think of the billions of years it took for gravity to weave the first stars into the first galaxies. Think of the incredible violence of a galactic collision and the quiet beauty of the new stars that rise from the wreckage. The universe is not a collection of objects. It is a collection of processes. It is a story of movement, change, and connection. Thank you for exploring the grand dance with us. The deeper we look into the cosmos, the more we realize that everything is connected, from the smallest atom to the largest supercluster. If you want to keep following the threads of the cosmic web, make sure to subscribe and hit the bell icon for our next episode. We still have so much to discover about the dark forces and bright lights that shape our reality. Until next time, keep looking up, keep wondering, and remember, even in the vastness of the dark, the dance never stops. Safe travels through the stars.